Hello everyone, my name is Michelle, and today we're going to learn about imaginary and complex numbers. So let's get started. What are imaginary numbers? So, up until this point, all the numbers you've been learning about have been real. Numbers like 5, 6, -3, the square root of 15, and pi are all real numbers. As the name implies, imaginary numbers aren't real. We represent imaginary numbers using the imaginary unit. I equals the square root of -1. Oftentimes, you will be asked to simplify imaginary numbers. Let's try a few examples. So, for example A, we can simplify this by first splitting it into two parts. We can split it into the square root of -1 and the square root of 16. You can recognize that the square root of -1 is just I, and the square root of 16 simplifies to 4. We can combine our final answer and we get 4i. For example B, we can do the same thing where we take out the square root of -1, and the other part will be square root of 15. We know that the square root of -1 simplifies to I, and we can't simplify the square root of 15 down any further, so our final answer is just I times the square root of 15. On to example C. We'll start out the same way by taking out the square root of -1, and we'll have the square root of -1 times the square root of 32. We can simplify the square root of 32 using the tree method. Of course, use whatever method you want, but I prefer the tree method. So we'll find multiples of 32, 8 and 4. Find multiples of that. Circle the prime numbers. And since we're working with a square root, we're going to find pairs. So that's going to simplify to I. Or we found two pairs, this pair here and this pair here. So we'll multiply those twos together. You get 4, the square root of 2. And this 2 inside the square root is the 2 that wasn't with a pair. We can put this all together and we get 4i times the square root of 2. On to example D. Again, we can take out the square root of -1. Simplify the square root of 12 using the tree method. And we get I times 2 times the square root of 3. This time we do have something in front of the radical, so we're going to multiply that, or we're going to put it back. So our final answer will be this 2 times that 5, so 10 x I times the square root of 3. I'm going to circle those so it'll be a little more clear. Next, what are complex numbers? So, complex numbers are real and imaginary. So they have one part that is real, one part that is imaginary. And the real part is A, and the imaginary part is BI. So complex numbers are written in the form A plus BI, where A is real and BI is imaginary. Some examples of complex numbers are 5 plus 6i, 6 minus 2i, or -3 plus 12i. Let's try out adding some complex numbers. So adding complex numbers is a lot like adding variables. All we have to do is combine the like terms. So on example A, we have 2 and 5. Those are like terms, so those are going to make 7. plus. And then 8i and 2i are like terms because they both have I. So it would be, our final answer would be 7 plus 10i. On to example B. 9 and negative 8 are like terms, so we'll add them together. Adding a negative is the same as subtracting, so we're actually doing 9 minus 8, and we get 1. And we will combine the negative 6i and the positive 6i and get 0, so our final answer is just 1. For example C, our like terms are negative 2 and 3, so we'll combine those and we'll get a 1. And negative 10i and 3i are also like terms, so we'll add those together and get negative 7i. So our final answer is 1 minus 7i. Let's try subtracting complex numbers. Subtracting complex numbers isn't all that different from adding complex numbers. So we just have to combine like terms, but we have the add step of distributing in the beginning. So we're going to have to remember to distribute our negative. So in example A, we're going to distribute our negative to the 3 and 2i. So when we rewrite it, we will have 1 plus 5i minus 3 minus 2i. And then we're going to combine like terms, the 1 and negative 3, and the 5i and negative 2i. So we will get negative 2 plus 3i. On to example B, we will distribute our negative again to the 3 and the negative 8i. And when we rewrite it, we will get 7 minus 4i minus 3 plus 8i. We're going to combine like terms, and we will get 4 plus 4i. On to example C. Again, we're going to start off by distributing our negative to the negative 5 and negative 2i. When we rewrite it, we will get negative 10 minus 3i plus 5 plus 2i. And we're going to combine our like terms, and we will get negative 5 minus I. Alright, so now we're going to try multiplying real and complex numbers. So the reason we're not multiplying complex numbers together right now is because the imaginary number I has some special rules when it comes to exponents, and we're going to touch on that on another video. Alright, so example A. We're going to start by distributing the 2 to the 4 and the positive 8i. We'll get 8 plus 16i, and that is our final answer. For example B, we're going to distribute the negative 2 to the 4 and negative 3i, and we will get negative 8 plus 6i. Now we are moving on to dividing real and complex numbers. So we're not dividing complex numbers for the same reason we're not multiplying complex numbers. Now, just because there's some extra steps that goes into it, and we're going to touch on those in another video. So let's start with example A. So this might seem really familiar. What we're going to do is we are going to do 6 divided by 3 and 12i divided by 3. And we're going to get, so we're basically distributing the 3. So we're going to get 2 plus 4i. That's our final answer. For example B, we're going to do the same thing. 4 divided by 2 minus 5i divided by 2. 4 divided by 2 is 2. We can't divide 5i by 2, so we're going to keep it as is. So our final answer is 2 minus 5i divided by 2. On to example C, we're going to rewrite it again. It's negative 8 divided by negative 12 plus 3i divided by negative 12. Negative 8 divided by negative 12 is 2/3 plus 3i divided by negative 12, which is I negative 4. And we are going to rewrite this with the negative not in the denominator, so let's write 2/3 minus I divided by 4. So all I did there was move the negative. Alright, so now it's your turn. Here are some examples of all the operations we practiced today. So I encourage you right now to pause the video and come back once you've had some answers. Alright, so I assume you paused the video, and now I'm going to go through them. So for example A, we're going to add this together by combining like terms first. -6 plus -7, which is -13, and 3i plus 3i, which is 6i. For example B, we're going to subtract. So we first have to distribute our negative to the 18 and positive 2i. When we write it, we will have 2 plus 4i minus 18 minus 2i. Then we will combine our like terms, and we will get -16 minus 2i. For example C, we're going to multiply by the real number, so we're going to distribute it to the 2 and positive I, so we'll end up with -2 minus I. Finally, we have example D, where we're dividing by a real number, so we're going to distribute the divide by 9, so we'll get 3/9 plus 6i divided by 9, and 3 divided by 9 simplifies to 1/3, plus 6i over 9 simplifies to 2i divided by 3. And in this case, we can actually rewrite this as 1 plus 2i divided by 3. Alright, so now we're going to put everything we learned together, and we're going to do this by using GermDOS, which is order of operations, and you might recognize this as PEMDOS or PERMDOS or something like that. In general, it's telling us that we should do the numbers in the grouping first, then multiplication and division from left to right, and addition and subtraction from left to right. Alright, so let's start on example A. So we are going to do the numerator first, and we are going to combine like terms. The 12 and the 8 become 20, and the 3i and the -6i become -3i. And we're going to divide that by 2, and we get 10 minus 3i over 2. And I kept that 3i over 2 because it actually doesn't divide. So on to example B, we're going to solve these leftmost parentheses first. We're going to distribute the negative and rewrite it, so we get 4i minus 2 minus 4i. The positive 4i and negative 4i cancel out, and we're left with this -2, which we're going to multiply by this -2, and our answer is 4. Moving on to example C, we're going to work inside the parentheses first. We're going to add this together by combining like terms. So we get 12i. Combine these two, we get -12. Then we're going to multiply all of this by 8. And our answer is 96i minus 96. Finally, on to example D. We're going to work inside the parentheses again. We're going to add these together by combining like terms. We have 10, and combine these together, and we have -2i. Then we are going to subtract -6i, combine like terms, and we end up with 10 minus 8i. So we are at the end of the lesson, so time to go over the conclusion. So in conclusion, the imaginary unit is I equals the square root of -1. When we're simplifying imaginary numbers, the square root of -x equals I times the square root of x. Complex numbers are real and imaginary numbers in the form a plus bi. And below that we have addition, subtraction, multiplication, and division. So throughout this video, I hope you can see that I acts a lot like a normal variable, and when we do operations on it, we can treat it like a any other variable. Alright, so that's all I have for today. Thank you everyone for watching, and I hope you learned something today. Have a wonderful day.